Hi everyone! So for today, we'll be working on the solution for the credit problem set. So in this problem set, what we want to do is to be able to key in a credit card number, and the system must first identify if it's a valid credit card number. If it's valid, it must then identify if it's a Visa, American Express, or MasterCard. So we're given some information about the characteristics of the cards. So for example, Visa card numbers contain 13 digits and start with 4. American Express, which I will refer to it as Amex, card numbers will contain 15 digits and start with 34 or 37. MasterCard numbers contain 16 digits and start with 51, 52, 53, 54 or 55. So now let's look at the structure of our code. We will first prompt the user to key in an input and identify if the card number is valid. If the card number is invalid, the system will then throw out the message invalid. But if it's valid, it will go on to identify the type of credit card number it is. So first, let's prompt the user to key in the card number. Since the user will be keying in a card number, the card number key in cannot be less than 0. Hence, we must include a validation rule in place to check that the input is not less than 0. Let's work on this first. So we'll start with our usual headers first. So that would be include, then include CS50. Okay, the usual headers int main void. Now what I'm going to say is that there is going to be a long integer and we'll call it as card. So what happens is that now I'm going to add my validation rule that shows that we're going to prompt the user for an input, and as long as the card key in is less than 0, this loop must keep repeating until the user keys in a valid input. So we say that there's going to be an input called card. So we will get long and we'll prompt the user for card number, right? And this will keep repeating as long as the card key in is less than 0, right? So now I'm going to write a comment as to what is happening in this step, where the card number must be greater than 0. Next, we need to identify if the card is valid. This is where Luhn's algorithm will be used. As per the problem set description given, it talks about how we use the Luhn's algorithm to determine if the credit card number is valid. So there's a few steps to this. Firstly, starting with the second last digit, you need to multiply every alternate number by 2. Then, you need to add these products' digits together. So do note that it's the digits that we're working with. So for example, it would be 8 plus, not 12, but 1 plus 2 plus 2, and the total will be 13. Then you will add this to the sum of digits that were not previously multiplied by 2, starting from the last digit. So this means your final sum is 20, and since the last digit of this is 0, that's how you know the credit card is valid. So if you do all these steps and the last digit of your final sum is not 0, that means that the credit card is invalid. And this is what we need to do. So now we need to write all these by code, and I know it seems like a lot, so let's go step by step. So firstly, we need to pick out every alternate number starting from the second last digit. So in the credit problem set walkthrough video, we are given a hint to use the modulo operation, which is represented by the percentage sign, to find the last digit of a string of numbers. I know we need to find the second last digit, but this will give us an idea of how to do that. So let's first start by understanding how the modulo operation can help us to find the last digit of a string of numbers. The modulo operation will give you the remainder of a division. That is, for example, if we take 4298 divided by 10, you can see that the quotient is 429 and the remainder is 8. So this is because the last digit is in the ones place and it cannot be divided by 10. So what this means is that 4298 modulo 10 will be 8, which is the remainder of the division. Right? So you can see that 4298 modulo 10 equals to 8, which is the last digit of this string of numbers that we have. So trying again with 5612 as another example, dividing 5612 by 10 will give you the remainder of 2, which is the last digit. So 5612 modulo 10 will give you 2. So now based on this, how do we find the second last digit of a string of numbers? So if 4298 modulo 10 gives us the last digit, what would 4298 modulo 100 give? So let's look at this, right? So 4298 modulo 100 will give you 98. And we will then need to process this one step further, taking 98 divided by 10 to give you the quotient, which is 9. So that is how you find the second last digit. So now if we need to find the fourth last digit, how do we do that? So since the fourth last digit is 2 places away from the second last digit, this gives us a hint on the pattern that we need. So if we take 4298 modulo 10,000, where we added 2 zeros since we are looking to find the digit that is 2 places away, we get 4298. Then processing this one step further again, taking 4298 divided by 1000, where I added another 2 zeros, we get 4. So can you see the pattern that we're getting? Where in order to find the alternate numbers that we need, we will add 2 zeros to our formula as we move down the string of numbers. So back to the example, since we are working from the back, I'll refer to my second last digit as card 1, the fourth last digit as card 2, and so on until I have card 8. So to find card 1, we will take card modulo 100 divided by 10. And since card 2 is just 2 digits down, I will take card modulo 10,000 divided by 1000, and I'll repeat this where I add 2 zeros for each step since we're looking for alternate numbers. Now we need to multiply each of these digits by 2, so we just need to add that at the end of each line where I put in a multiply by 2 for every line. Now we need to add these digits together. So you can see that the largest possible digit per placeholder is 9. When multiplied by 2, the result is 18, which is still a 2-digit number. So this means we now need to define the new value of each placeholder to be the sum of its digits. So for example, up to this point, card 6 is 12 because we took 6 times 2 will give us 12. But now we need to define that card 6 should equal to the sum of its digits of its current value, which is 1 plus 2. So this means that card 6 will equals to the first digit plus second digit. And we actually covered this through the use of the modulo operation. So now, card 6 should equals to card 6 modulo 100 divided by 10, which will give you the first digit, plus card 6 modulo 10, which will give you the second digit. So we'll need to do this for card 1 to card 8. Okay. So now, moving on to the next step, we need to add this to the sum of digits that were not multiplied by 2, starting from the last digit. So earlier on through the modulo operation explanation, we already learned how to find the last digit. So for the last digit now, let's label it as card 9, with every alternate number being card 10, card 11, all the way to card 16. So to find the last digit of the string of numbers, which is card 9, we have card modulo 10. So card 10 will be similar to what we did earlier, where it will be card modulo 1000 divided by 100. So again, we add in 2 zeros because we are moving 2 digits down. And for every subsequent alternate number, we'll add 2 zeros. So now let's sum this all up together. So we need to do this for card 1 to card 8, and now we represent it by sum 1. So sum 1 equals to card 1 plus card 2 plus card 3 all the way to card 8. So sum 2 will be equals to card 9 plus card 10 plus card 11 all the way to card 16. And now to find the overall sum, I'll just use it as sum 3 equals to sum 1 plus sum 2. So now with this overall sum being sum 3, we want to check that the last digit of this final sum we get is 0. So if it is not 0, the system will print invalid. If it's 0, then the card is valid. So we'll use this by saying, if sum 3 modulo 10 is not 0, the card is valid. Okay, so now we're going to put it all together here. I will declare that there's going to be an integer to expect, so we'll call it integer card 1. So remember, we were labeling all the numbers alternate numbers that we're looking at. So I'm just going to say that they're going to be these integers that the system can expect to be coming in soon, all the way to card 8 first. Okay, so now remember what we're going to do now is that we're going to identify what are the every alternate digits. So in this case, card 1, as we talked about earlier on, will be card modulo 100, and we'll divide it by 10, and we will multiply it by 2 as we had discussed earlier on. Okay, so now for card 2, remember we talked about it being 2 digits away from our card 1, so I will just add 2 more zeros, right, and divide by 1000 because I'm adding 2 more zeros as I'm just trying to move down 2 spaces. So I will times 2 again, right, and then I'll repeat this for all the card numbers, where I'll just be adding 2 zeros from the previous line, right? So what happens is that now I'm going to just write for cut 4. So a little way that I'm going to do this is just add 2 zeros at the end, 1, 2, and 1, 2, right? So now I'll have cut 5, just two places off, yeah? Okay, so that's the method that I'm going to do to find out what are the every alternate numbers that I need for my card number starting from the second last digit. Okay, so now moving on, what we need to do is that we need to update the number of card 1, where we need to actually split the first digit and the second digit. Okay, so this is also what we discussed earlier on. So what happens is that now I need to further split the card 1 into the first digit plus the second digit. So now I'll just take card 1 modulo 100 divided by 10 plus, and this is how I'm going to find the second digit, 10. Okay, so for card 2 we're going to do the exact same thing. Modulo 10. Okay, so this might not be the neatest way to do it, but it gets the job done. Okay, so just to repeat myself, what happens is that I've already found my values of card 1 to card 5, and now I'm doing the next step where they are saying that I need to actually sum up the digits of each number itself, right? And this is part of Luhn's algorithm. And last one. Oops. Okay, there you go. So now what happens is that I'm going to sum up all these digits together first. So I'll just call it sum 1, right? So that would be, add it all up together. Let me just wrap the line so it's neater for us. Okay, so I will have summed it all up together, right? Now let's move on to the next section where we say now we need to find the digits that were not multiplied by 2 starting from the last digit of the card number that was keyed in. Okay, so remember what we did is that we actually labeled them card 9 all the way to card 16. So I just need to declare what are these again. So I just need to write that there will be incoming integers to expect that will be labeled card 9 all the way to card 16. Okay, so we have 9, 10, 11, 12, 13, 14, 15, 16. Okay, so now what I need to do is that I just need to pick out what are these digits. So remember what we did is that we actually used the modulo operation to find out what is the last digit of the card number key in. So we take that as card modulo 10. Right, so again, we are just looking for the next alternate number, so that will be 2 spaces down. So it would be something similar, right? Divided by 100. I can't multitask. Okay, so card 11. I'm just gonna keep quiet and focus on this. So again, since we're going just 2 digits down, we will just need to add 2 zeros to that. So again, card 12, right? Then we have card 13. And last one. And yeah, so that is what we have now. So now we actually need to sum it all together. So I'm just going to say, I will sum up the second part that we have found out first. So that will be cut 9 plus cut 10 all the way to cut 16. Okay, now I'm going to sum this all up together, so that I'll put it as sum 3 equals to sum 1 plus sum 2. Okay, so if you don't want to write in the extra step of sum 1 and sum 2, you can actually just straight away go to sum 3 and add up cut 1 all the way to cut 16. That is fine also. Okay, so now what we're going to do is that we're actually going to move on to the next step, where we need to find out what is the last digit of sum 3. If it is 0, then that means that the cut number is valid. If it is not 0, then the system will need to throw out the error message that the cut number keyed in was invalid. Okay, so now what I'm going to say is that there's going to be an integer that we'll call as length, and we'll start from 0 first. Okay, so now what I'm going to say is that if sum 3 modulo 10, which we'll use to find out what is the last digit of sum 3, if it does not equals to 0, right, what I want the system to do is that I want it to print a string, right, and the message will be invalid. Okay, so if it actually prints invalid, what I want the system to do is that it will actually stop running here, and I'll put it as return 0. Okay, if I do not put return 0, what this means is that it will print invalid, and it will actually continue to run for the rest of the steps that I'm trying to key in. Okay, but the thing is that once we identify it as valid, the program can actually just stop running, and that's why we will put a return 0 here. So now, having determined that the card number is valid, we need to identify if it's a Visa, Amex, or MasterCard. So let's start with Visa first. The number of digits will equal to 13 or 16, and the number starts with 4. So how do we find out what is the first digit of the card number? We will do so by dividing the card number by 10 until the quotient left is a single digit. So let's take 429 for example. The quotient of 429 divided by 10 is 42. Dividing this by 10 again, we get a quotient of 4, which is the first digit. So we'll let the card number key in equals to Visa. So as long as Visa is more than or equals to 10, we will keep dividing this number. So to put it into code, while Visa is more than or equals to 10, we'll keep dividing the quotient by 10, and this is represented by /equals. Okay, so that will be how we find the first digit of Visa. Next, for American Express, we know that the number of digits is 15, and it starts with 34 or 37. So how do we find the first two digits of the card number? Since we know that it's a 15-digit number, we can actually divide the card number by 10 to the power of 13, which will be 13 zeros, and that will actually give you the first two digits. So we'll let the card number key in equals to Amex now, and divide this by 10 to the power of 13. Okay, so that will actually throw out the first two digits of the card number, which we are trying to find out to determine if it's an American Express card. Similarly for MasterCard, we know that the number of digits is 16, and it starts with either 51, 52, 53, 54, or 55. So similarly, we'll divide the card now by 10 to the power of 14 to find the first two digits. So we'll let the card number equals to Master, and we'll divide this by 10 to the power of 14 to find out the first two digits, and then we'll use it to check whether it starts with 51, 52, 53, 54, or 55. Now, let's put all this together in C. Okay, so assuming the system identifies that the card number is valid because the last digit of sum 3 equals to 0, it will actually move on to the subsequent steps where it needs to identify if it's a Visa, Master, or Amex. Okay, so now I'll just write another comment here. Now we need to differentiate between Visa, Master, and Amex. So this is what we need to do. Okay, so to start off, right, what we realize is that no matter what type of card we're looking at, be it Visa, Master, or Amex, we need to know what is the card length. Okay, so earlier on here I already have said that there's going to be an integer called length, which will represent the length of the card. So we're going to say that while card is more than 0, so as long as the card number is more than 0, right, what we want to do is that we want to keep dividing the card number by 10, and that will actually give us the length of the card number that we're looking at. Okay? So first we will identify whether this card is a Visa. So let's put a comment. Okay, so what I'm going to do is I'm just going to scroll up to this part and declare that I will have a long integer called Visa, right, equals to card, long Emacs equals to card, long master equals to card. So this is because for every subsequent section that I'm going to write, right, I'm going to say that I'm going to work with a Visa, Emacs and MasterCard. Okay, so for this section, we're going to first identify if the card is a Visa. Okay, so while Visa is more than or equal to 10, okay, we're going to divide Visa by 10. Right, so if Visa equals to 4, because we want to see that if the card number starts with 4, and the length, right, that we have found equals to 13 or 16, okay, then we want the system to print a string. And we will say that this card is a Visa. Okay, likewise again, once it identifies that it's a Visa, we're just going to return 0. So the program will stop running and it will stop here. Okay, so if it goes through and realizes that it is not a Visa, it will move on to the next step. So now it will try to identify if the card is an Emacs card. Okay, so similarly, like what we went through just now, while Emacs is more than 10 to the power of 13, right? So it will keep dividing it. Okay, so if the length equals to 15 digits, which is the characteristic of a MasterCard, and it starts with 34 or 37, okay, then the system will print a string to say that it's an Emacs. And then again, if it identifies that it's an Emacs, we will return 0. Okay, so if it's also not an Emacs, we'll just move on to the last step, identify if the card is a MasterCard. Okay, so likewise again, ten to the power of 14. So these are all what we worked on earlier on, okay? So if the length is 16, and we're going to talk about the different numbers that the MasterCard can start with, which will be 51, 52, 53, 54, or 55, right? Then the system will print a string and it will say that it's a MasterCard. Okay, and then if it's a MasterCard, it will return 0. And for all other cases, it will just print that it's an invalid number, right? Because it did not fit the criteria. It did not fit the criteria of it being a Visa, Emacs, or Master. So let's just put in a final invalid. Okay, so now let's give this a try. Okay, so I see that there's an error here. So now let's go and look for that. So it says around here, it expected a close here, right? So let's try that. Okay, let's try again. Okay, so now it compiled. Okay, so now we're going to just try another card number. Let's try Hello. Let's try. See, so it says invalid. So let's test it with more input. I have a sample card here. So let me just run it again. Yep, so this identifies as a Visa. Now let me try a MasterCard now. And it identifies as a MasterCard. Now one last time now, I actually have an Amex card number here. And yep, there you go. This is the solution for the credit problem set. So if you found this explanation helpful, I'd greatly appreciate it if you could drop a like, or maybe you could subscribe to my channel, as this would really help with the YouTube algorithm in bumping up my videos for others to watch too. And yeah, thank you so much and have a lovely week ahead.